Hi everyone. In this video I am going to explain about the operation of parallel in parallel out shift register followed by the VHDL program. So parallel in parallel out shift register. So we know the purpose of shift register is to shift the data bit by bit. Okay. So whether the data is coming out parallelly or the data is going inside parallelly, that depends upon the type of the shift register we have used. So in the last two videos, I have explained about the serial input side, serial input, serial output, serial input, parallel output. Now, two more shift registers are there, parallel in, parallel out, parallel in, serial out. In this video, I am explaining about parallel in, parallel out shift register. So PIPO means parallel in, parallel out, parallel in, parallel out shift register. Okay, so what do you mean by parallel in, parallel out? Enters data enters parallelly and data leaves parallelly. So data enters into the shift register parallelly, at the same time data enters into the shift register serially. Okay, so consider 4-bit parallel in, parallel out shift register. Consider 4-bit parallel in, parallel out shift register. See here, for 4-bit operation we should consider 4 flip-flops because each flip-flop is capable of storing 1 bit of information. So for n bit shift register we need n number of flip-flops. So data as enters it into the shift register parallelly, all the flip-flops individually they are having the input. This is data input D of 0, data input D of 1, and data out input D of 2, and data input D of 3. And similarly the data is coming out parallelly, so all these lines says that data is output parallelly. So D out of 0, D out of 1, D out of 2, and D out of 3. Okay, and what is the relation between them? See, now if you look at this particular flip-flop, this is D, this is Q, DQ, DQ, DQ. If you look at this stage, we can understand that all the flip-flops are working individually. They are taking the data and they are just passing the data to the output. Okay, there is no relation among these flip-flops. So to have a relation and to work synchronously, what we are doing, we are taking the clock signal which is common to all these flip-flops, so that the input and output operations are being done parallelly among all these flip-flops. That is only the link or sync between these flip-flops. Okay, this is the clock signal which may be at working at the rising edge. Okay, hope you understand. See, the data enters parallelly. This is a parallel data. All this one is parallel data in, and all this one is parallel data out. Okay, so data enters in parallelly, data is coming out parallelly. This is what the parallel in, parallel out shift register. Okay, now coming to the VHDL code, which is written in behavioral model. So library IEEE, use IEEE dot std underscore logic underscore 1164 dot all entity parallel in parallel out shift register is port of data input which is of size 4 bit. So std underscore logic underscore vector of 3 down to 0, and again data out is also same, output std underscore logic underscore vector of 3 down to 0. Now what else we have? Reset pin is there, clock pin is there. These two are inputs. Reset, clock. See why reset and clock is not added here like previous case, because data input is of 4 bit size, but reset and clock are both are single bits. Input underscore std underscore logic, that's it. End parallel in parallel out. Now coming to the architecture behavior of parallel in parallel out is begin, process, and inside the process instances which changes the output is nothing but clock only. Again begin, if reset is equal to 1, then see when reset is equal to 1, output, all outputs of the flip-flop should be cleared. So what is the output? D out. D out is equal to all are zeros. Next, if reset is equal to 1, D out is equal to this one. After that, else if clock tick event and clock is equal to 1, then otherwise you can also write it as a rising edge of clock. That simply says that the clock is changing from 0 to 1 and it is having a clock event. Then D out is equal to Dn. See here, whenever the rising edge of the clock occurs, whatever the data available at the input side, the same data parallelly moving to the output, because D in goes to D out. Coming to this here, see D in 0 goes to D out 0, D in 1 goes to D out 1, D in 2 goes to D out 2, and similarly D in 3 goes to D out 3. Hope you understand. That means all the bits from 0 to 3 in the input side will be moving parallelly to all the output bits 0 to 3. So that's why instead of writing individually as it is a parallel movement, we can write it as together D out is equal to D in when the clock rising edge occurs. And then end if, so end if, end process, end behavior, end process, end behavior. Okay, so this is parallel in parallel out shift register operation and as well as VHDL code. So in the next video I will explain about the parallel in CL out shift register, which is somewhat complicated compared to all these, because data has to enter parallel in serial out. Okay, data has to enter parallelly but leaves serially. So parallel entry data as well as the data which is coming from the previous stage will also be having a connection with the next stage flip-flop. Okay, parallel in serial out. See here, parallel in serial out. Parallel in serial out means data enters parallelly into the flip-flops. Loading is parallelly done. Loading done parallelly. Now once the loading is done, the data has to move serially bit by bit through the flip-flops to the output. throw the flip-flops to the output. So that's why we need an additional logic circuitry. We need an additional logic circuitry between the flip-flops so that that works for both the parallel loading and as well as shifting operations. Shifting operations. Okay, that is somewhat complicated than this. I will explain that in the next video. Thank you.